All right, everyone, welcome to another episode of the TWiML AI podcast. I am, of course, your host, Sam Charrington, and today I'm joined by Richard Socher. Richard is co-founder and CEO at U.com. Before we get into our conversation today, please be sure to take a moment to head over to Apple Podcasts or your listening platform of choice. And if you enjoy the show, please leave us a 5-star rating and review. Richard, it's been almost exactly 2 years since we spoke. You were at Salesforce then. Welcome back to the podcast.
It's great to be back, man. A lot has changed in those 2 years.
A lot has changed. I think the last time we spoke to you were like holed up in some exotic bunker, early in the pandemic. But we made that conversation work, and I'm super excited to get caught up with you. You've been a busy guy for the past couple of years.
It's been busy bee days, but exciting. Can't complain.
Awesome. Well, for those who don't know you, I'd love to have us start with you sharing a little bit about your background before we dive into what you've been up to recently.
Sounds great. Yeah. Hello, everyone. I'm Richard. Where do I start? I'm originally from Germany. Did my PhD at Stanford in deep learning for natural language processing and computer vision. And thought it would be great to have more people use deep learning for natural language processing, which was still quite received with quite a lot of skepticism back then. And so I started teaching at Stanford deep learning for natural language processing in 2014. And needless to say, nowadays it's kind of obvious that that is the right technology after 4 years for a variety of reasons. But one being that everyone was then teaching deep learning as the main approach for natural language processing. I stopped teaching. My main job was doing a startup, MetaMind, an enterprise AI platform. We got acquired by Salesforce, where I became the chief scientist. And then build out the research group there, and eventually also a lot of the AI product engineering teams that I led. And then couldn't quite shake this idea off. I actually, during the last couple of days of my PhD, I'd implemented a first little prototype of a new search engine that was going to summarize the web for people and be just much more useful and quicker. In Google, at the time, I thought, oh man, all my smart friends are going to Google. No one's ever complaining about it. Where, as far as I can hear, it's just maybe too audacious of an idea. But I couldn't quite shake the idea off over the last 8-9 years. And after many amazing, wonderful years with great teams at Salesforce, I decided I think I need to do this. I think the world needs a better search engine for a lot of macro reasons as well as sort of user reasons. And so I decided in the summer of 2020 to start this with Brian McCann, one of my amazing collaborators and coworkers, both at Stanford and at Salesforce. And yeah, couldn't be happier with Brian and the team we've built at U.com.
When you talk about the meta and user reasons for a new search engine, what exactly does that mean? What's the motivation for U.com?
Yeah, so and the high level reason, it's kind of crazy that the entire economy is moving online, and you have the single gatekeeper in the beginning of most people's online journey that mostly wants to sell you to the highest bidding advertiser and you and your queries. At the same time, we are in an information age, and there's information overload. 20 years ago, it was hard to get access to information, but nowadays it's almost too easy to get access to a lot of not that useful information, and you need AI to help you deal with this flux of information, help you summarize all the things that are going on and get quickly to what you want to actually achieve and do. And you give that intent usually to a search engine, but now 60% of all Google queries are zero clicks, meaning they don't leave the Google ecosystem anymore. They stay within YouTube, within Maps, and they try to suck you into these engagement loops rather than trying to be as useful as they can, summarize, and then get you on your way, either somewhere else onto the internet, or just that you execute on the intent that you have. So if I search for how to do a sort array by value or something in Python, I just want the code snippet. And that's what, in U.com, one of the many, many features that we just give you. There's a code snippet and a copy and paste button, because we know that that's probably what you want instead of a list of 10 links and you go there and you don't have good string matching and whatnot. So those are just one of many examples that's helpful for the user, connects to the macro. Then there's sort of, outside of AI and machine learning reasons, and just that when every company has to pay this tax to exist on that first page, which is, by paying for ads, it creates some really odd incentives that I've observed now. I had multiple people kind of tell me a story where they got organically up in the Google ranker, and then they started to make millions of dollars because the content was just good. And so Google Ads team comes over to sales team and say, hey, do you want to buy some ads to get even more traffic? And they're like, no, we're good, we're getting so much traffic. They basically disappeared and went to page 9. uh,
Oh,
and
wow. Yeah.
and then they're like, sorry, yeah, we'll buy the ads. And then magically they come back to page 1 with their ads too. That's kind of one of the many reasons to do it. And then in some crazy way, also now people are actually complaining more and more about just the ranking and the relevance. You have all these SEO microsites that kind of try to reverse engineer the algorithm that Google decides for everyone what to see and read and consume. And buy, and they're trying to reverse engineer it, and so you get all these like really odd microsites that have a bunch of sort of language model samples on there that are known to resonate well. You look for like good machining tools for like building a roof or something, and at the bottom there's some weird Wikipedia article about California on the page that comes up highest on Google. It's because they know, oh, that stuff ranks well in the algorithm. So there's all this reverse engineering, and I think part of the problem there is that, and it's partially an AI problem, but it's also a systemic problem, and how you approach AI is that Google decides and wants to be able to decide for everyone what they read, consume, and buy, because they have so much power by then showing you mostly ads, which is also just becoming 90% of any page of the results that,
Yeah.
when you actually want to buy something and have a
It's
monetizable
gotten pretty
way.
bad in my experience. Like it's degraded surprisingly over the years.
Yeah. And so I think it's important to help people still get stuff done, but not just try to do that through ads, and by giving them also some control. So we have, of course, a large neural network too to rank. What we actually think about more is the apps that you're looking for, like big content islands like Reddit, things like that, stuff where, social signals that people actually care about rather than SEO microsites. But we actually give people control and say, oh, I like this source or I don't like the source. And that way, if you try to manipulate this too much by playing sort of, SEO games, people will just downvote you and you'll disappear. And so I think giving people control over the AI that influences so much of their information diet is yet another reason. I could go on forever. There's so many reasons why, but yeah, it's also one of the most exciting AI applications that's so important in an information age. It tackles summarization, which is one of the big, hard, unsolved problems in AI, and so on. It's just the most exciting thing. I couldn't not do it.
Awesome, awesome. When starting to build a search engine in 2020, do you start with something that's fundamentally similar to a page rank type of an approach, or are you approaching it very differently?
Yeah, it's a good question. We are actually approaching it quite differently. We have not sort of replicated the list of blue links. We're getting that from an API. But what we actually are doing is using large neural networks to understand what the intent actually is, and then try to give you the most useful application. And we want to be a much more open platform for building these applications out so that different people can actually implement and contribute to that first page of the internet and make it very, very seamless. And so we have essentially relied much more on the content and the semantics. And then, of course, we can nowadays already extract a lot of popularity signals that you used to need PageRank for, because a lot of like recipe sites and code snippet sites like Stack Overflow, they actually have votes on how popular something is. So you can extract that. That's part of the signal together with the natural language processing signals.
So, on top of the kind of core search engine, you also recently announced a couple of extensions. Well, at least the code is new. Is Right new also?
Yeah, it's a lot of new stuff's coming out. We're thinking about how can we be more useful. And of course, if you build a search engine nowadays, the really tricky balance is how many of your resources do you spend on just catching up to Google versus how many resources do you spend on doing something that's different that Google doesn't yet do, right? And I'm sure in the beginning when people saw Google Flights, they're like, oh, why does a search engine help you book flights? And we get similar things now when we write an essay for you, like you search how to write an essay about World War II or the American Revolution and, this and that. It'll just write you an essay and you can, modify it and then generate new ones. And that helps you with blank page problems of like, okay, how do I start? You can want to write a blog post about, your Airbnb project or whatever it is. And so we think like that is something unique that AI can also bring. We have these exciting large language model applications now twice in the search engine. One is in code completion. So if you look for how to do something in Python or other languages, the code complete app comes up, and it's just a full-on like GitHub Copilot like model that essentially just auto generates the code that you're looking for. And then of course you have Stack Overflow apps with copy and paste buttons. You have simple tutorials and to sort of get you started with things, and you have Hugging Face and PyTorch kinds of official documentation too. And it's all just right within their first page with code snippets and copy and paste buttons to be very easy. And then on the writing natural language, side, we have this uWrite app under u.com/write, where you basically can have an AI just write an essay or blog post for you.
Got it. So kind of stepping back, you've got AI throughout this platform. You've described a couple of applications that are, I don't know if you think of them as part of the search engine or kind of adjacent or on top of the search engine, but then you're using AI as part of surfacing relevant results to folks. Thinking about that core, maybe dig a little bit deeper into some of the ways that you're using machine learning to deliver relevant results to folks. Do large language models come into play there, or is it more on the summarization side?
Yeah, it's a great question. There are a bunch of summary features too, and AI is sort of both in terms of our product, sort of very deeply, and we can get into that like intent classification, slot filling, ranking of different applications, and so on. It's also a user persona that we know a lot about and care a lot about, just people who program AI applications, and hence we have all these specific tutorials and documentation sets for Hugging Face, for instance, for PyTorch, and a bunch of other things. We have GitHub issues. We crawled all of GitHub, so you can find all the different issues about your code that you're working on directly, all in the search engine. When you basically trying to understand a query, you want to understand like what programming language someone is using, or if you say I want directions from San Francisco to LA, it's kind of a standard example. This is a good one for slot filling, where you want to extract sort of certain things from the query directly and input them into an app, and then basically let people immediately kind of have that filled out, the slots of the from direction, the to direction, so you get the time that it takes you to drive somewhere, and the directions for that. So that is an example of slot filling that we have to do for 150 or so apps that we have. If you look for DAO jobs or Web3 jobs, for instance, then we kind of extract that's the kind of job type you're looking for. And we have a bunch of apps that basically show you job listings for these kinds of categories. So slot filling is a pretty big part of the search engine. Then, of course, you have the intent, kind of knowing, oh, this is just the weather intent. And that leads then to influencing and kind of end-to-end training a large ranking model that basically ranks all these different apps in terms of their priority for helping you get something done.
And so when are the intents or the apps, are those kind of top down, created by you or a project manager? Hey, we're going to need our travel app. We're going to need our directions app. We're going to need, this list of, hundreds of things. Or are they kind of bubbled up from the queries that people are making themselves?
Yeah, great question. You bring up two good points. One is namely privacy. We care a lot about privacy. I think it's really important right. And so we have a private mode in which we don't track anything. So we don't know really what people are doing. We don't have the queries, but we also have a personalized mode. And so some people actually want to give us feedback, and tell us what they want. So we have a very active community of thousands of people that give a lot of like feature requests. And it's kind of tricky sometimes because search touches really everything, right? Everything we do often online like starts with search. And then we also can look at sort of churn queries, like things that people tried to do that they couldn't do, and then they leave forever. And so sports was a good example of that just kept bubbling up, people wanting to see sports results. And so we now have actually releasing this week a bunch of results for sports that are live coming in from different APIs, so you can kind of see what's going on. So yeah, it's a mix of uh, direct feedback and then some indirect feedback.
Can you talk a little bit about the ways that you're using summarization? You've referenced that a couple of times.
Yeah. I think summarization in the limit is actually one of the hardest and most interesting and impactful NLP applications of our time right now, because we're in an attention economy and in the information age. We need better summarization, but really, if you think about it, if you're deeply ingrained in a space and you want to get a summary for a new paper, it's very different to when you've never read anything in that space, right? I sort of because of this protein generation model I've been working on at Salesforce. I've been reading a lot more bio papers, and like there's just so much lingo that you don't know. If you were to try to summarize that and make it even shorter, you would not understand anything. And so the summary might need to simplify things, but also add some explanations for some things. And then you think about things where you're an expert, like, oh, the Elmo paper was basically like the contextual vector Cove paper, but instead of translation, they use language modeling. And then BERT was essentially like Elmo, but instead of an LSTM model, they use a transformer model. And so that's like a one sentence summary. If you know exactly what all of these things mean already, you're like, boom, I get it. And their models are larger is probably also a good add-on to that summary. But if you don't know what a language model is, what a word vector is, what a neural network is on LSTM and BERT and all of these things are, then these are non-useful summaries for you. So long story short, summary, super interesting, super hard AI problem. But for us, we're to say, okay, well, we don't know that much about what a user knows. How can we start with something that's useful for pretty much everyone? Where we started is basically with coding. Like if you look for this, here's like the most relevant code snippet. That's in some ways a sort of multimodal. If you think of programming as a different modality to natural language, multimodal kind of summary. And then another one is just pros and cons. So if you look for best headphones, for instance, you want to just extract what are the main pros and cons of this particular headset. So we kind of extract those from professional review sites. So you can very quickly skim a bunch of results and know what are the pros and cons of the different headphones. Another one is recipes. We heard a lot of people complain about having to read the whole life story of someone if they just want to get like a lasagna or chocolate chip cookie recipes. So we extracted like, here are the ingredients, here are the 10 steps to actually make the cookie, and then you're done. So those are examples that you already see in the product on you.com that where you can just kind of see a useful summary that pretty much for everyone is going to be universally useful.
And are summaries, the way that you're using them, are they tending towards more generative summaries versus extractive summaries, or do you use both in different places?
You have to kind of use both. Our values are trust, facts, and kindness. And if you think about it, as much as I love these language models, you can't quite trust their facts yet, right? They make stuff up, right? You can just say, write me an article about how Hillary Clinton won the election, and it'll write you a perfectly reasonable sounding article how that happened. And
Mhm.
so the veracity and just like factual correctness of large language models is still iffy sometimes. So you can't just let them generate. You might get some pretty not so great tasting cookies if you just do that. So you have to start with some clear extractions, but then you can kind of simplify things and get rid of redundancies for multi-document summarization and things like that.
Hmm. Hmm. Your example reminded me of one of the issues that came up with Google sometime this past year, where I think it's just one of these examples of you type in a query, what should you do if, someone's having a seizure, and like it extracted the list of things not to do.
That's right.
And, I'm curious if you could talk about, in the context of using similar technology and trying to present information, in a similar kind of summarized way, like how do you, when you're starting from the ground up, build guardrails, so that you can achieve this level of trust that you're aspiring to?
Yeah, it's a good question. I actually think you have to keep your users and yourself and the use cases in mind. And the more important a use case is, the more important it is to really have some human oversight. I love AI. I think AI can change anything from cow diets to reduce methane to agriculture to medicine and creating new protein structures and all of these different things. But when it comes to like life-threatening information, you still need to have some human oversight. So, for instance, when you ask like how to commit suicide, we just have a handcrafted message that your life matters, and don't do it. Here's a suicide hotline. You don't want some AI to kind of do that. And of course, there are some interesting sort of chatbot applications too to have longer conversations with someone who's thinking about this. And I think like companies like Replica, where full disclosure, I'm an investor too, have done a phenomenal job kind of being essentially a journal that talks back to you and seems to care about you, and kind of helps you work through issues. So there are some exciting and interesting applications in that space as well. But yeah, we are basically thinking about the more impactful the application is, the more careful we have to be in just letting AI run off and do its thing.
You know, when you were working on MetaMind, I'm imagining that you had to be pretty far out in the let's call it the research domain to get these raw tools to do the kind of things that you wanted them to do. How much has that changed or not now? Like, are you able to are you using mostly off the shelf stuff, or thinking, are you required to do a lot of research oriented things, novel architectures or novel training methods, or that kind of thing?
Yeah, it's a great question. I think it's actually gotten so much easier to build AI companies and just functionally like useful algorithms. It's been really incredible to see. Like back in MetaMind, we still built those CNNs in C++. Like
And so it sounds like the your general take is that there you have a lot more ability to kind of pull things off the shelf, um and the you have raw horsepower there that you're not kind of needing to push the innovation frontier in that way.
yeah, so that I think you can build a lot more. You can have a lot of impact with the applications. In fact, we've done so much research that you can just have, I think, currently more impact in just applying that research to all these different domains and problems that you see in the world and workflows that are not yet automated as much as they can, than you could, I think, in pure research right now. It's kind of been, in terms of pure research and sort of major ideas, it's been mostly executing on make the models larger, efficient to optimize and parallelize on current hardware, and get more training data, and collect that training data in reasonable ways and think about the bias, and so on. And the models haven't really changed. And honestly, even if like there's a different kind of model, we just need a very large general function approximator that's efficient and has enough knobs to tune. And then you can kind of optimize that whole setup. My hunch is if it wasn't for the particular hardware that we're using, we would probably we could use any other large model too. I think LSTMs aren't inherently worse. They're just like less easy to optimize and parallelize and train henceforth, on our current hardware. So that's one aspect of the answer. The second one is we definitely have to still innovate because there is no Hugging Face model to build a neural network ranking mechanism that takes into consideration your intent, your slots, and then 150 of the apps that we built for the first time ever and no search engine ever had before, and then ranking them properly. So you do still have to innovate and build brand new models. Now, for now, we can't really publish those. I actually hope that at some point we are safe enough as in terms of the existence of the company that we can be much more open in the future. But yeah, so the answer is, of course, we still have to massively innovate because of these hard and interesting new problems that we're tackling, where we also don't have that much data, right? So large language models enable us to know that if you look for a Chinese restaurant near me or an East Asian restaurant in my area or close to where I am, and all of these things, they all mean the same thing. That was something that in the past you couldn't know, and you would have to get a ton of training data and then be able to actually map them all to a similar kind of natural language, API language to then trigger. So you essentially have to translate human language into the language of computers and APIs. So there has to be a lot of innovation on our side for that. And then maybe a last note, since we brought up MetaMind, is that back then MetaMind tried to do, I think, so many different things, like help you kind of label your data and drag and drop it into the browser. That's Scale and Crowdflower now, and Scale is like an $8 billion company or something. That piece of itself, that was just like one of the many features of MetaMind. And then deploying it and scaling that deployment and helping you do error analysis, and then just making it a simple Python interface to actually run your AI classifier or model in production. All of these things now have companies that are valued in the hundreds of millions or billions of dollars. Each of these separate features that we had implemented MetaMind from scratch, pre having anything like PyTorch or TensorFlow. And so it's just fascinating how good the tooling has gotten for AI. And that was sort of my tangent on, like, we're investing in both vertically integrated but also sort of tooling companies at AIX Ventures. And because of that, it's gotten a lot easier for people to have impact in those applications.
You referenced the particulars of the hardware that you're using. Is that to say that you're using kind of non-traditional exotic things, or just that there's this affinity between GPUs and transformers that allows you to scale?
Yeah, there's we definitely are using very standard hardware because we need to scale. We need to be able to fill up a data center in Europe or in Asia and in different places. So we don't really want to rely on any non-standard hardware right now. And even GPUs are often, there's a shortage. So we have to sometimes map some of the GPU models and see if we can make them fast enough on a CPU, just so that we can have more data centers and have less lag time when there are not enough GPUs available in certain geos. So yeah, it's an interesting challenge for sure.
And how are you finding the level of maturity from an engineering perspective to allow you to achieve that kind of scale?
I guess it's just about the people. Like, we've gotten really lucky in having hired like an incredible AI and engineering team, and also DevOps. Just like spawning out all these machines with a click of a button. You have a whole new data center and reduce latency for people in a different geo. It's yeah, mostly about the people. And
I'm imagining you've invested significantly in kind of building out a enabling platform that allows you to kind of develop and train models quickly and get them into production quickly. Was that a big focus?
Yeah, that's definitely it's definitely something. We also are relying on things like weights and biases. Full disclosure, I'm also an investor in them to help with experiments and running those. And there are a lot of good tools that you can use now, but ultimately to actually spawn out the whole system and like have a new end to end search engine that runs with a bunch of different machines and so on, they're all communicating. That is still something that we had to build ourselves from scratch. And then we also want to make it easy to create a new application. So now we just have it so that you have a new JSON like data dump, and then boom, with like a config file, and you have a new application within u.com. And so I'm excited to, in the future, essentially let anyone kind of build that and have search capabilities over all that data. So I think automating search over new kinds of data sets, that has been, an interesting and tough challenge that we tackled.
Hmm. Uh, we spoke a little bit earlier about the code module, code application. In a lot of ways, the kind of the use case that you described of, hey, I'm searching Stack Overflow. Really, I just want this code snippet. I think I mentioned that in a conversation with Greg Brockman about Codex. How that's ultimately what we want. What we need. In terms of the process of building that module, can you maybe compare contrast with what you've seen others do around Codex, Copilot, that kind of thing?
Yeah, I think there's basically, I think about this in kind of two levels. Either you're trying to solve a problem that people have solved before, and at that point you just want the direct code snippet as is, or you're
Hmm.
trying to combine it and have sort of a new combination of problems that no one has yet quite solved like this before. And at that point, you need like Codex or like our Code Complete in u.com to just give you the answer and generate something novel. And it's kind of incredible how these models aren't just kind of able to deal with things inside the convex hull, but really in the hypercube of like different combinations and combinatorial combinations of things they have seen in the training data to just generate and combine them. So that's kind of how I think about these two levels of generation.
It's a ground up model that you built as opposed to an API that you're using
No,
from
yeah,
someone else.
we're also using API for the code generation. Yeah.
Oh, for the code generation, you are. For the models that you're building, what are some of the training data sources that you rely most heavily on?
I guess there's sort of large scale internet available data that is there, and then we have to crawl a ton too. So that is probably the biggest one, and it's been something that I think a lot of machine learning leaders can relate to, which is everyone wants to come in and build cool models, and but then they realize, man, that's really hard, so they download Hugging Face models and they just kind of work out of the box. And then the biggest thing is that everyone wants to not very few ML engineers want to spend a lot of time on data, which led Andrew to say, "Oh, let's just have data competitions of like whoever can get the most interesting data set for this problem." And that's something for us that often meant we had to spend a lot of time crawling, and eventually we just hired some people who are actually excited about crawling data and getting us that data that we need to then be able to actually train summarization models, and so on. Later on. And so yeah, it's been a continuous challenge to crawl, and it's one of the many places the monopoly of Google comes into, because there's some sites that say only Google's allowed to crawl us, no one else is, and they're like, well, how are we ever going to beat Google if we can't do that? And so there, yeah, all kinds of interesting challenges, both on the technical side, but also the sort of systemic side.
Okay. You mentioned earlier when I asked about PageRank, I thought your response was saying that you weren't crawling for kind of the index, but rather you are consuming that via an API. So is it that's the index, but you are crawling for some of these other applications you're building? Is that the idea?
Yeah, sorry, that was yeah, there's some ambiguity there. So we actually think that the list of like a blue link of lists, a blue list of links isn't going to be as important anymore as, the actual larger content islands like Reddit, like Medium, like Twitter, and so on. And then in order to be able to summarize things, you also can't really do that on the fly. These large models are not fast enough. People want things in hundreds of milliseconds, and took us a long time to for 90% of queries now be faster than DuckDuckGo and other competitors in the search engine space, and almost as fast as Google, at least when you're close to our data centers. We don't have as many all over the world, of course, but long story short, we are actually crawling a ton of data in order to build these apps and make them fast enough. There are also several times where we thought we could rely on an API from someone else, but then just the scale and burstiness of search, and when you get tens of thousands of queries in a few hours, like you just no API was able to deal with that. We had to build and have that content ourselves, index it, be able to do interesting vector search operations and things like that with the data all in a few hundred milliseconds to then be able to surface the right kind of content very quickly. So yeah, we're kind of slowly crawling the web through the most important content islands like Stack Overflow, like GitHub, like PyTorch or Hugging Face documentation, or all of Medium, which is also pretty large. So there are a bunch of interesting things that we are, we have to crawl ourselves just to be able to have the speed and the AI capabilities that you have to run offline.
The goal is to produce a better general search engine, but you've also specialized in some ways that makes it a super interesting search engine today for more technical folks. Yeah, how do you think about like when you hit the knee of the curve that it's like better for everyone?
Yeah. What we've learned so far is that we're better for developers already. Like a lot of people, I posted a couple of features on a Twitter thread for our, Ucode kind of special search, and it blew up like crazy, hundreds of thousands, like 300, 400,000 impressions, thousands of likes. And so it resonates a lot with that crowd. Now,
Mhm.
what we've learned is that I sort of jokingly say, it turns out developers are people too, and they want to know what the weather outside is and what the sports results are and how to travel and like all of these things. And so, where to buy food and maybe order food. And so we have to basically, if we want to be the best search engine for developers and be your default and be there every day and in your nav bar through, Chrome extensions and things like that, we have to be able to do everything else in search too, which is tough for a small startup. But we've now gotten to a point where once we launch sports results, there's maybe only the travel category where we're not as good for everyone else. And then most other things we actually are, we have answers for movies and things like that. And, there are still some APIs like the movie API that is a little bit slow. So it takes like 2 or 3 seconds to load rather than less than 1 second, and we've gotten complaints about that also, but yeah, there's some proprietary data that we could probably just scroll. I guess the law just kind of changed a little bit because LinkedIn lost a big lawsuit, that they tried to prevent folks from crawling data. But long story short, a lot of crawling is happening, and the speed is always super important. And we are having to build a lot of that in house.
Mhm, mhm. Of course, congrats on the launch of U.com and U.com code and write. Before we part ways, I did want to circle back on a couple of the things that we spoke about. That you started at Salesforce. It sounds like you're still working on those. The protein generation one. We spent a fair amount of time talking about that the last time we spoke, and we'll include the link to that in the show notes. We didn't, I don't think, spend much time talking about the AI Economist. I think the timing didn't quite work out to dig into that. So would love to have you share a bit about that project, and I think you have some recent news there. Any recent updates?
That's right. This week in machine learning, we actually got the Science Advances paper out about the AI economist. And maybe just at a very high level, what is the AI economist? It was worked by Stefan Chang and Alex Trott and a few others at Salesforce and myself. And basically, the idea is using reinforcement learning for some of the most important applications that we can think about for humanity, period. Instead of having RL play games that are kind of interesting, but ultimately themselves not very useful, why don't we see if we can build a very realistic simulation? And we're far from that in terms of realism right now. This will have to scale up over time too. But I think it's a brand new area of AI that can have a huge amount of impact. And so the high level idea is you have a two-level reinforcement learning problem where you have an RL agent that sets taxes and subsidies, for a bunch of other RL agents that which themselves are just trying to optimize their own utility, as in they try to maximize resources they can collect, money they can make, houses they can build, blocking off other people from resources by building houses around them, things like that. And are basically to some degree more selfish, and but may also eventually identify patterns to collaborate towards their own selfish goals, and maximizing their own utility functions. And so the interesting thing is now you can give that top level RLA agent, that sort of the AI economist, the ability to subsidize or tax different income groups differently in order to maximize a specific objective that you've given that AI. So the idea here is that you can now say, oh, I want to help the middle class, or I want to maximize productivity of this economy, or I want to maximize equality in this economy, or a combination of all of these things, that you weight and you say, okay, I care about the one we chose in the end was productivity multiplied with equality, which is 1 minus the Gini index. It's essentially thinking about how equal you want to be. You don't in the limit, you don't want to be like everyone is extremely equal but extremely poor, right? That's not helpful too. So you have this like overall productivity in there as well. And so that is kind of the high level. And so what that means is that if you take that idea and you really scale it out and you make the simulation more realistic, you increase the size of the number of agents to hundreds of thousands, and you actually put in sort of historic data into this, that to start the model, that in the future, if a politician says, oh, I'm doing like these following 5 things to help the middle class, or to help this particular group of people, whoever it is, like worldwide, right? Then you can run that suggestion across and compare it and contrast it with millions and millions of years of simulated taxation, where you basically try to identify what the fairest or best or most sustainable or most equal or most productive way is to tax that entire system. That touches on highly philosophical things like communism, capitalism, socialism, market economy, and so on, and combinations of these systems on the one side. But it's very concrete. Like it'll could change and be another input into economists' models to be more realistic. It's kind of crazy, but there's models that are being used right now, like the SIS formula, a very famous Berkeley professor in economics, who has this provably correct way to tax different income brackets. But it's provably correct in a one-step economy. It turns out people iterate, right? Like turns out time moves on.
Yeah.
And so this AI economist model can actually recover the provably correct solution for a one-step economy. But then as the models learn, as the agents adapt, as the time continues, like that model just is so much more powerful and realistic than any of the linear models and one-step models that we're currently using, that it's just hard for me to not see how that won't change all of economics, which in the grand scheme of things has been an area that hasn't been impacted by AI nearly as much as I think it could or should. And if you think about how much bloodshed there has been in human history to identify what the right model is of taxation and representation and things like that, like it's just so powerful to be able to try to offload that into a simulation, get millions of years of taxation going, and then learn from that and see if we can use some of these things. And of course, like we don't want like an AI dictator either. Like we need it as like another data point, as a model that helps us make more more accurate like decisions. But ultimately, people still want to decide what the objective is. So that's still like a very important one. And you have to sanity check it, of course, before you implement these things. So I'm not like absolutist, like this has to be like a new religion or anything. But like I think it's just such a powerful tool, and I have high hopes that just like what we've seen in linguistics and natural language processing, what we've seen in computer vision, what we've seen in robotics, what we've seen in self-driving, all of these different application areas of AI, that economics could be another such application area.
Sounds like a model that would be really good at The Sims.
That's yeah, it's not actually crazy to think that that is like a pretty good simulation. Now, of course, the problem is that it doesn't capture like sort of as realistic utility functions that people have. Like in The Sims, like people might not get as tired and then like just don't want to work anymore because they want to sleep and things like that. So you want to adjust. And for most people, like there's sort of logarithmic happiness curves too, like making like an order of magnitude, you need to make an order of magnitude more money often in order to be like a little bit happier, and then it sort of levels out logarithmically. There are all kinds of interesting things that we have found in psychology. But what's fascinating too is that you can actually say, well, I think people are this and that. Like, I think people are going to want to work more or want to work less. You can actually make that very explicit in the beginning of the simulation, and then see how those assumptions about how people, define their own utilities will actually influence the optimal political model. Or not political, to some degree, if you kind of group all of these different policies into one cluster, but just generally sort of taxation and financial.
And does the work on behavioral economics, things like predictably irrational, all of that, does it say that, kind of akin to what you're saying, that everyone has their own utility functions and they're not as uniform as traditional economics might like? Or, is it more that, there's just an emotional, irrational component? And if that is the case, like, how do you even model something like that?
Yeah, it's a great question. So you can have a prior distribution, and then you sample different, like you sample from that prior distribution that you have, for instance, for utility functions, and then based on that sample, and based on how you define your prior distribution, you can get different sets of agents that come out of it. And so that's one aspect, and then there's some things where the irrationality has not been captured yet as realistically in that simulation. Just the idea that sometimes people do something that they know is actually suboptimal for them, but they think because of fairness they want to still do it. And so those are not yet modeled in the simulation that we ran. But at the same time, those RL agents that have neural networks and can try to adjust their behavior to others and so on, still much more realistic than anything that economists use nowadays, which is like often linear models and one step kind of like provably correct formulas.
And have you published the models themselves or the simulation environment?
Yes, it's actually extremely important. Imagine someone is like, I know what is right for everyone, and the AI said it. Let's all trust it. That's of course a terrible idea. So you have to open source these models. You have to open source all the assumptions you made that went into the simulation and the simulation itself. That could be some pretty insidious bugs, right? If you said, "Oh, this is how everyone's going to get taxed," and then there was a bug, and you're like, "Oops!" So a lot of people need to do this, and that's one thing I loved about Salesforce research too, and still love that for these kinds of important human kinds of applications, we did open source all of that model, and there's some really exciting ongoing projects now that you can use this also to avoid things like tragedy of the commons, where it's like old example of if all the sheep farmers put all their sheep into one field and the field just gets completely destroyed and then no one has a field anymore for any sheep. So you have to kind of partner up and make sure you don't use your resources too much. It's something that I think we're going to hit worldwide in terms of sustainability and deforestation and things like that, and water. So we all have to kind of avoid tragedy of the commons in like sort of worldwide. Yeah.
Given the meta factors that we've talked about, with regard to the way revenue models impact, search engine behavior, like how does U.com become a viable company if it's not going to be ad based and fall into the same traps that we saw with Google?
Yeah, great question. So the main goal is to have these applications that we're building actually provide enough value that people would want to pay for them. You write is one example. Costs a lot of money to run a large language model. As it writes a blog post for you or an essay, like you can pay for that. That's one thing. I also think that private ads can be used, especially in our private mode where we don't log anything, we don't know what's going on at all, and we can't really monetize it in any way other than through private ads. And what I mean by private ads is just ads that are dependent on the query. And that's a luxury that you can have as a search engine because people give you an intent of what they want to do. If you're a social network, they don't really tell you like, I want to buy an air purifier right now. They just talk to their friends and be like, oh, I keep sneezing or coughing, and maybe I have dust mites in my home. And then you kind of have to like spy on them if you want to sell them ads to like know what they might want to buy in the future. But as a search engine, even if you don't know anything about the user, if you just look at a query and then you, based on that query, give an ad, I think that is better. And it's kind of what we've seen DuckDuckGo doing too. They care about privacy as well. And they have these private ads that basically are not user dependent, they're only query dependent. And the advertisers don't really know which user is seeing the ad, and just it's just basically really only based on the query. And so I think that that can be kind of a backup, but I really hope that we can build something that's useful enough that people are going to want to pay money for certain things.
Well, Richard, it has been wonderful catching up. Again, congrats on the recent launches and all the amazing work that's gone into building what you've built over the past couple years, and looking forward to catching up again soon.
Thanks so much, great questions, and yeah, been a pleasure chatting with you.